What's up? What's up? What's up? It's your boy, the network. And today's topic is section 3.26D, virtual link. This is a topic in the CCNP route exam. It's going to be soon called the CCNP Enterprise exam come February 23rd, 2020. Let's go ahead and take a look at the exam blueprint to see where we came from and where we're headed. Hashtag labeveryday. This is the exam blueprint. Implementing Cisco IP routing, also known as the CCNP route exam. We just wrapped up the section 3.26C, internal router, backbone router, ABR and ASBR. Today we're going to be doing virtual links, and then finally we're going to move on to configuring and verifying Ospf path preference. I'm not too sure if I'm familiar with that. But anyways, what is a virtual link? A virtual link, if you remember in the area types video, we talked about the different area types, right? We said when we're designing an OSPF network, we have to start off with area 0, right? Which is also known as the backbone area. And all the other areas, like area 1, area 2, area 3, etc., must connect to the backbone, right? Well, let's say you hired a network engineer who doesn't know very much about OSPF design, and he just somehow created a network that does not physically connect to the backbone. Or the guy that was designing the network before you got hired on didn't design it so that way all the areas connect to the backbone. Well, we can sort of create a band-aid, and that's called a virtual link. Let's take a look at the slides to get further information on that. So what is a virtual link? Official definition: all areas in an OSPF autonomous system must be physically connected to the backbone area. Area 0. In some cases, this is not possible, so it might not just be because we hired an inept network engineer. You can use a virtual link to connect to the backbone through a non-backbone area. That area is called transit area, if you remember in that video that we talked about the different area types. You can also use virtual links to connect two parts of a partition backbone through a non-backbone area. So if you look at this topology here at the bottom here, we got area 0, which is the backbone. Remember, every area must connect to it. Well, if you look at this design, area 1 does connect to the backbone, right? But on the far right, area 2 does not. However, he can still communicate to the backbone by going through a virtual link. And that's what we're going to do. We're going to fire up GNS3 and go through the configurations of a virtual link and kind of fix this problem here. So it's basically a design problem, and we're just kind of fixing that issue. Here's another example of that. We use this one in the area types video. If you notice, area 0 is the backbone, right? There's area 1, which connects to it, and then there's area 2, which is not connected, because remember, all areas must connect to the backbone. Well, area 2 did not connect to the backbone, so in other words, we have this transit area. We're going to use this transit area to communicate back to the backbone, right? And area 1 will be considered the backbone, but the link that we create, it will be called a virtual link. Here are the configuration commands to configure the virtual links. You configure virtual links with the following command on the ABR. So if you look at this, remember what ABRs are, right? Area border router. So this router borders an area, that router borders an area. So we must configure it, the virtual link, on those routers using this command. We do area number, virtual link, and then the remote ID. So we do, for this one, we would say the remote ID would be router 3's router ID. And when we put the command over here, we put the remote ID as router 1. I believe. I don't think it's router 2. I believe it's router 1. We'll double check because I haven't really gone through this lab. So we could also configure virtual links with authentication. So we can basically put a password so that way not everybody can create a link through our network. And to verify it, we do show IP OSPF virtual links. Let's go ahead and fire up GNS3. Y'all know what it is when y'all see this little girl. And experiment with OSPF virtual links. All right, so here's the topology we are going to be working with. Notice we have, let's look at the routers first. Somehow they're called, well, let's read this. You are a freelance network engineer specialized in routing and switching. Shout out to networklessons.com. Renee Molnar, this is where I got this website. I'm sorry, I always say that. GNS3volt.com. That's where you can get this topology here. I'll leave a link in the description below. One of your customers, a local butcher, I guess that's why we have meat here, has some trouble setting up their OSPF network. Some of the networks are not reachable, and it's up to you to provide them with a SOLU. I didn't even know what that word meant. Had to Google that. Apparently means like bliss. All IP addresses have been pre-configured. Each router has a loopback interface. As you can see, we got chicken, beef, pork, and fish. They have loopbacks 1, 2, quad 3, and quad 4 respectively. We're going to configure Ospf on all routers. I'm going to skip that part because that's general housekeeping. I'm going to have to basically create neighbor relationships between all these guys. What I will record is restoring connectivity to the discontiguous backbone area. You remember what discontiguous means, right? So that's like, if you think about the United States, y'all know I always compare roads to network and the highways, right? The contiguous United States are everything that's in the, let me pull up a map here. Okay, so you look at this map here. All these states connect to each other, right? All of these states connect to each other. They are called the discontiguous 48 states, right? All the other states that don't connect, like Alaska, which is far up north, and Hawaii, which is out in the Pacific Ocean, they don't connect to the United States. However, they're part of the United States. So that's why we call these states that connect to each other the discontiguous 48 states, even though there's 50 states, because these two states don't connect. So it's similar to how an OSPF network design that's chopped up like this, we fix it with a virtual link. So we're basically creating a virtual link from these contiguous 48 states to Alaska and or to Hawaii. I'm going to go ahead and pause it right here and create neighbor relationships between all these guys and bring us right back. All right, so I'm done with all the IP addressing between all the routers. I've configured Ospf on all the routers as well. However, if we take one more look at this, I just realized this. If we take one more look at this topology right here, we got area 0, the backbone here. We also have area 0 over here. However, this is listed as like the network 3.3.3, and this is basically quad 1. So if we go to beef, you'll see he has Ospf neighbors. Let's go into beef real quick. Show IP Ospf neighbors, and as you can see, we got 3.3, 4.4, 1.1 respectively. Those are all the IP addresses of 3, 4, and 1, right? So 3, 4, and quad 1, right? So he has Ospf neighbors of all of them, but he sits in area 1, and all of his interfaces are in area 1, all of them. So the first thing we need to do is, if you notice, pork doesn't really sit in a backbone. So we need to make these two neighbors, right? So let's go to pork real quick. Show, no, that's beef. Shout out to Rene Molnar again for creating these. He always create these, like putting Easter eggs in these routers and stuff like that, or making the host names kind of funny. He puts a story behind them. So show IP Ospf neighbor, and you can see his only neighbor is quad 2. Who is that? That is beef. So that's his neighbor. He doesn't have an Ospf route to this location right here. So what we're going to do is we're going to create a virtual link through area 1 to make it over there. We could do it vice versa, but we're just gonna actually, you got to do both ways. So it's going to be similar to this. So remember, area 0 is going to transit through area 1 to make it to area 2. So similar to this slide. Let's route console in the router pork. As we are in there already, we are going to go to global config mode, and we are going to say, we said we got to go into routing process, do area number, virtual link, and the remote router's router ID on the ABR. So in this case, pork will be the ABR, and then chicken is also the ABR. He is not an ABR, he is an internal router. So let's go into pork and go to the router config mode. I believe it's Ospf process 1, but let me verify that. Show IP protocols. Do show IP protocols. And yes, we're in Ospf process 1, so we're going to go into that, router Ospf 1, and we're going to say area 1. We got to do area 0, sorry. You do area 0, area 1, 0 rather, and then virtual link, and then the IP address of the associated virtual link neighbor. So we are trying to create him as a virtual link neighbor. What's his router ID? I believe it's going to be quad 1, but let's go into chicken and find out. Do show IP Ospf, and his router ID, as you can see, is quad 1, right? So we'll go back into pork, 1.1.1.1. We can also do authentication if we want. We may or may not get into that now. We ain't gonna do any authentication today. We'll just create virtual link and move on to the next topic. So we do that. and we're going to go to the remote router, which is chicken, and do the same thing, but put pork's router ID. So we're going to chicken, and we are going to go into router config mode, ospf1. We're going to say area 0, virtual link, and that other router ID was pork, which is do show IP ospf, or rather protocols, and we can see his router ID is quad 3. Paste that bad boy in there. I need to fix that. I was trying to experiment with connecting that, and we can see that did not come up yet. I believe we had to do area 1. So that's my bad. We have to put the transit area. We have to put the transit area. So in this case, the transit area is area 1. So in order to get to this area, we need to go through area 1. So that's what we need to do. That's why we haven't gotten up yet. So let's do that. Virtual link quad 3. Let's do the same thing on the other side. So that's my bad, y'all. Notice there's a mismatch ID here. I'm glad we did this. So we got an error. So we need to fix that and change this to area 1. So we put the transit ID there. So that's the area we'll get if we have mismatched area IDs. And notice we got OSPF virtual link 1 loading to full. So we got a neighbor now. So we go to pork, and we can see, remember he had only one neighbor here when we did it at that time, right? And now if we do a show IP OSPF neighbor, we can see now he's got 2 neighbors. So now he has a way to get there. There's the interface, OSPF virtual link 1. I'm glad we did that. Yeah, I'm glad we did that. So now we have to create, notice how area 2 is not connected to the backbone, right? Fish is not connected to the backbone. So how do we do that? We're going to create a virtual link. We can create a virtual link through here, or we can create a virtual link through here. And also you can do this with GRE tunnels. That's not very common. So we're just going to create a virtual link. Let's create a virtual link to pork. So remember, our transit area is going to be area 1. So we're going to travel through area 1 to make it to the backbone area 0. So we're going to console and a fish and basically do the same thing. Exit. We are going to go to router OSPF1, and we're going to say area, the transit area, the area you're going to go through, and then virtual link, and then the router ID of who you're trying to get to. So who are we trying to get to? We're trying to get to pork. His router ID is most likely quad 3, which we verified that earlier. So quad 3. Oops, my bad. 3. And we have to do the same thing on the other router, on pork. So we're going to go into pork and basically do the same thing. Notice we have a mismatch area ID here. So we need to do the same thing and create a virtual link. So area, do the same thing and do area 1. Router ID is quad 4. So we're going to say quad 4. And notice how we're getting that mismatch area ID again. And now we have a neighbor that's going up. We probably should have, let's see if we got some time to do some authentication here. Well, before we do that, let's check our neighbors. We're going to stay here and do a show IP OSPF neighbors. And notice now he's got 3 neighbors. So we've got virtual link 1 and virtual link 2. So basically we have a virtual link going here and we have a virtual link going here. Let's also run one more show command, which was, let's do the same thing on this guy and create some authentication. We're going to create a virtual link from fish to that backbone area, same backbone area. I don't know if we could do that on we're going to create 2 links here. Well, maybe we should be able to create 2 links on fish. So we're going to go to fish, and we are on the router. We're going to say area. We're going to travel through area 1, virtual link, and then the remote ID, right, which is quad 1. So from here to here, remote. So we're going to go through area 1. Remote ID is quad 1, right? We're going to set up authentication this time. I haven't experimented with this, so we'll see how this goes. Quad 1. It says here authentication type. We're going to say, authentication. And we're going to say authentication key and we're going to put the key. We'll say it's bruh 5. We're going to do the same thing on the other side, but we're going to leave out the key. Right? We're going to leave out the key and see how that goes. So we're going to go from here, from chicken, we're going to travel through area 1, to make it to fish, who is in area 2, right? And his router ID is quad 4. So back to chicken. Notice how we're getting, I believe, a mismatch error right here. We're going to go to router. We are in the Ospf 1. We're going to say area 1, virtual link. The remote's router ID is quad 4, right? Quad 4. And then we're going to say authentication. Notice we still have the mismatch area ID here. We are going to try to put the key now. Let's see if we got any more errors. We still have this error right here. Invalid packet mismatch area ID. That went away. Still not a neighbor with him yet, though, I don't believe. Let's see what happened here. Let's do show IP Ospf neighbor. He doesn't have quad 4 as his neighbor. So let's go ahead and do that with the key and say it was bruh. Forgot the key already, y'all. It was bruh 5, right? Bruh 5. Did that work? Do show IP. There it goes. Went up. Now we have a second virtual link. So perfect. We did the same thing, but except this time we added an authentication key. So do show. Remember, he had only 2 neighbors, which was 3 and 2. So 3. He had pork as his neighbor and beef as his neighbor. And we should theoretically have fish as his neighbor. Do show IP Ospf neighbor. And there we go. Quad 4, quad 3, quad 2. Notice we have Ospf virtual link 2, virtual link 1. Perfect. So we was able to add authentication to that. Another flavor to it. Let's also run one more show command, which was, remember, to verify virtual links, we use show IP Ospf virtual links. Let's run that and see what information we get from that. So we're gonna go to pork. Actually, we'll go to chicken and see what we got. Show IP Ospf virtual links. And there's our virtual links. We got a virtual link 2 to router quad 4. Where's that? From chicken to quad 4 is there. So that's our virtual link that we're looking at right there, that first output. We also have here simple password authentication is enabled, like we just did right now. We have a full adjacency. There's information about the hello and dead timers, the Ospf network type. We have the cost, etc. We also have virtual link number 1, virtual link 1, and also virtual link 0. For some reason, this one is down. Not too sure why. But virtual link 1 is to router quad 3. Where's that? From chicken to quad 3. Chicken is right here. Quad 3 is to here. So that's the virtual link that goes through area 1 to port. It also tells us network type, pretty much same information there. Hello and dead timers, when the hello is due, the adjacency state, it's full right now, so they're Ospf neighbors. And the 1 to quad 3 right here, 0 is down. Maybe that's the one that we did wrong earlier. Because notice there's an infinite metric right there. But yeah, that's pretty much it. We could let's run that command also on fish and see. There was only one, there should be only just one virtual link there. Show IP Ospf virtual link, and we got 2. My bad. That was yeah, one had the password and one didn't. So notice it says simple password. That's the one to quad 1. So from here to quad 1, we had the password set up. We also had another virtual link here with no password. That one is virtual link 0 right there. That's all I got for y'all today. That is my YouTube page. Please subscribe. When you click the subscribe button right in the bottom of this video, there should be a bell right next to it. You click that bell and that'll let you know. That's the notification bell. It'll let you know when I put up these videos. I'm trying to turn these videos as fast as I can. The deadline is coming up I mean, it's all the way up in February, but we still need to get this up so that way I'm sharing this knowledge, and we are going to try to get certified, y'all. Please comment, like, subscribe to the network.